In this video, we'll talk about collision theory, energy diagrams, and 4 factors that affect reaction rate. So here is a diagram of an endothermic reaction. There are 5 key points you need to know, which is that this represents the energy of reactants, energy of products, change in energy, activation energy, which is the energy needed to start a reaction, activated complex, which is the transition state. So before I explain the 4 factors, we need to understand what a collision theory is. So collision theory states that in order to reactant particles, they must collide. And for a collision to be effective, particles must collide with sufficient energy and proper orientation. So what that means is that they need to collide with enough kinetic energy, and they must hit each other in specific areas of the particle. Now I'll talk about the 4 factors. So temperature. If you increase temperature, this increases kinetic energy. So it increases the chances of particles colliding with sufficient energy. And concentration is, if you increase concentration, it increases the number of particles per volume. So an area is more crowded, therefore the frequency of collisions increase. Increasing surface area also increases the area of exposure. So if you increase the area of exposure, the chances of colliding with proper orientation increases, so the frequency of collision will increase. Catalysts and inhibitors are special ones because they directly affect the activation energy. So catalysts, they speed up the reaction by lowering the activation energy, so it becomes easier for particles to collide with sufficient energy. And inhibitors, they do the exact opposite. They slow down the reaction by raising the activation energy. And an important thing to know about catalysts is that they are not used up in the reaction, and enzymes are an example of a catalyst. If you turn into your worksheet for your energy diagrams and look at question 4. So question 9, I've already explained this diagram, so please take note. Question 4, number 1 with a catalyst. So because number 1 represents an exothermic reaction, the air energy of products needs to be higher. The air energy of reactants needs to be higher than the energy of products, which is represented right here. So before a catalyst is added, the activation energy is this. And after a catalyst is added, the activation energy is this. The reason for that is because catalysts, they lower the activation energy to speed up the reaction. But if the question was an inhibitor instead of a catalyst, you wouldn't draw it under the curve. Instead, you draw it over the curve as they increase the activation energy to slow down the reaction. Bye-bye.